Hello everyone, in this video we're going to explore relationships between quantities and learn how to recognize when these relationships can be described using a constant unit rate. So our objective today is that we will recognize when relationships shown in tables, diagrams, and verbal descriptions can be represented by a constant unit rate. So first, what is a unit rate? So a unit rate is a comparison where one quantity is expressed per one unit of the other one. So let's say we have 60 kilometers for 2 hours. Okay, so this is a rate, but it is not a unit rate because it's for 2 hours. In order to be a unit rate, we need it for just 1 hour, for 1 unit. So 60 kilometers in 2 hours, this is the same like 30 kilometers per hour. Okay, so per hour here means for just 1 hour, for just 1 unit. So we can call 30 kilometers per hour a unit rate. So let's start with Spark Your Learning. These salsas are made for a competition. We have 4 types of salsas here. We have on fire, and it uses 2 tablespoons peppers and 5 tablespoons tomatoes. Blazing, and it uses 4 tablespoons peppers, 12 tablespoons tomatoes. Kicking, it uses 6 tablespoons peppers, 15 tablespoons tomatoes. And Feel the Burn, 3 tablespoons peppers and 6 tablespoons tomatoes. And it says here, if peppers and tomatoes are the only ingredients in the salsas, and the names are based on taste, which 2 salsas should have the same name? Share your work and explain. So let's look again at the 4 types of salsas here. So on fire, blazing, kicking, Feel the Burn, you would see here different numbers in tablespoons peppers and tablespoons tomatoes. So in order to tell if these 2 types should name the same, it must have the same amount of peppers and the same amount of tomatoes. In order to make it easier, we can look for the amount of peppers in 1 tablespoon tomatoes in all of the 4 types here. So let's start with on fire. So if we say that, for example, P stands for pepper and T stands for tomato. Okay, let's make it like a table here. Okay, we'll do the same for all of the 4 types. So for on fire, we have 2 tablespoons pepper and 5 tablespoons tomatoes. We said in order to compare them, we need to find it for 1 tablespoon tomatoes. Okay, so if we need it for 1 tablespoon tomatoes, guys, if it's 5 tablespoons tomatoes, needed 2 tablespoons peppers. So in order to get it for 1 only, it's just you are dividing by 5. So you'll divide the amount of peppers also by 5. So 2 divided by 5, it's the same like 2 over 5. So it's just 2/5 tablespoon peppers to 1 tablespoon tomatoes. Okay, so this is the unit rate here. So this is for 1 tablespoon tomatoes, we have 2/5 tablespoon peppers. Okay, let's do the same here for blazing. And we can see here it's 4 peppers to 12 tomatoes. Again, we need it for 1 tablespoon tomatoes only. So in order to make the 12 one, it's like we are dividing here by 12. So if we divide by 12, we should also divide the amount of peppers by 12. So we have here, guys, 4 divide 12. It's like 4 over 12. Or you can simplify it by dividing up and down by the same number. Both numbers can be divided by 4. So it will be like 1/3 tablespoon peppers to 1 tablespoon tomatoes. Okay, so we will need this unit rate also. It seems like on fire and blazing are not the same, okay, because not the same amount of peppers on the 1 tablespoon tomatoes. Okay, so let's see cooking. We have 6 tablespoons peppers to 12 tablespoons tomatoes. To 15 tablespoons tomatoes. And we need it for 1, so we need to divide again by 15. So 15 divided by 15 is 1. What about 6 divided by 15? So 6 divided by 15 is like 6 over 15. And we can divide up and down by, we cannot divide by 6, but we can divide by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. So it's a 2/5. Oh, so 2/5 tablespoon pepper on 1 tablespoon tomatoes. It seems like it's the same like on fire, guys. So on fire and kiki, they have the same amount of pepper on the 1 tablespoon tomatoes, so they should be named the same. Okay, let's see fill the burn. So for fill the burn, we have 3 tablespoons peppers for 6 tablespoons tomatoes. So if we need it for 1 tablespoon of tomatoes, we need to divide here by 6. So what about 3 divided by 6? So 3 over 6, or you can divide by 3 up and down, and you will get a half. So it's like half tablespoons peppers on every 1 tablespoon tomatoes for fill the burn. So here, which two should be or should name the same? It's on fire and kicking. So the unit rate of kicking is 2/5 tablespoon peppers to 1 tablespoon of tomatoes. Or in other words, we can say that the 6/15 equal 2/5. It's like we just divided by 3 up and down. So on fire and kicking should have the same name. Also, one more thing, guys. If I asked you, which one here is the most chili? Okay, if you can see here that the biggest fraction here for the 2/5, a third, or a half, we can find that half is the biggest fraction. So half is greater than 2/5, half is greater than a third, so half tablespoons peppers for every 1 tablespoon tomatoes, that would make the most chili salsa. Okay, so fill the burn, it's like its name, it's the most chili. Okay, so let's have this example in page 6. It says the table shows how many ounces of salsa you get when buying small jars of salsa. Letter A, it says describe a pattern you see in the rows of the table. Okay, so what do you see here in the rows? In the rows like this, guys, horizontally. Okay, in this row and this row. Okay, what is happening here in the small jars of salsa? So 4 became 8, became 12, became 16. It's like that every time we are adding 4. Okay, and for the ounces of salsa, it's 32 became 64 became 96. So it's like we are adding 32. If you said multiply by 2, okay, it may be correct for the first one, But it doesn't work here on the second one. So if you say 32 times 2, it's yes, 64. But if you take 64 and multiply it by 2, it is not 96. So it is not a good idea. So here it's adding 32, because 32 plus 32 equals 64, plus 32 equals 96. So what should we write here? We can say each number of small jars increases by 4, each number of ounces increases by 32. Okay, letter B, it says describe a pattern you see in the columns of a table. So if you look at the columns, which is vertically, like this, guys, what is happening here to these numbers? So 4 into 32, it's like we are multiplying by 8. So 4 times 8, 32. And here 8 times 8 is 64. 12 times 8 is 96. So it's like the number of jars you multiplied by 8 to get the ounces of salsa. So how we describe it? We can say that the number of ounces of salsa is 8 times the number of small jars of salsa. Letter C, use your patterns to extend the table. So if you look at the rows here, for the first row, every time we are adding 4. So 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. What about 16 plus 4? That would be 20. Okay, the second row, we are adding 32. So we'll add 32 more to the 96, and we will get 128. You add 32 more, and you will get 160. Okay, letter D. You previously learned that a unit rate is a rate in which the second quantity in the comparison is 1 unit, such as 4 ounces per serving. Describe the relationship between ounces of salsa and small jars of salsa using a unit rate. So a unit rate here, it means just not for 4 jars or 8 jars or 12 jars. We need to know for every jar, for 1 jar. So if 4 jars, for example, have 32 ounces of salsa, how many ounces in 1 jar? So 4 jars, they have 32 ounces. If you need it for 1 jar, you just divide the 32 by 4. So 32 divided by 4, it's 8. 64 divided by 8, it's 8. 96 divided by 12, it's 8. So in every small jar of salsa, we have 8 ounces of salsa. So there are 8 ounces of salsa per small jar. The diagram shows how many ounces of salsa you get when buying medium jars of salsa. Describe the relationship using a unit rate. So if you see here, these are medium jars, not the small jars before. And we have here 4 medium jars, and they all together have 48 ounces. So he said describe the relationship using a unit rate. So using a unit rate, it means for 1 medium jar. If it's 48 in 4 jars, how many in 1 jar? So if it's for 4 jars and you need it for 1 jar, you will multiply or divide. Yes, we'll divide. You will divide the 48 ounces by the 4 jars, which is equal to 12 ounces each jar, okay, or per jar. Okay, so you can say here that there are 48 ounces in 4 medium jars, so there are 12 ounces per medium jar. Okay, second example. The tables show the prices and weights of avocados. The table on the left, you can see here, it's the number of avocados to the price, And on the second table, you have the number of avocados, but to the weight. Question A, it says, can the relationship between the price and the number of avocados be described with a constant rate? So he's asking for price and number of avocados. Which one has price and number of avocados? Okay, it's this one. So we can call this for question A. Okay. So what do you notice here, guys? The one avocado is $1.25. So if it's two avocados, you add $1.25 more. Yeah, if you add $1.25, you will get $2.50. So until now it's good. One more avocado, so you add 1.25. Yes, it's 3.75. One more avocado, you add 1.25. And again, you get $5. You add one more avocado, so the 5 will cost plus 1.25. The 5 will cost 6.25. So it seems yes, this is a constant rate. So we can say yes, the price per avocado is always $1.25. Okay, question B, it says, can the relationship between the weight and the number of avocados be described with a constant rate? So let's look at the other table. So it seems like question B is for this table. So here, the one avocado weighs 7 ounces. So 2 should weigh 7 plus 7, which is supposed to be 14, not 13. Okay, so it seems like not every avocado weighs 7 ounces, because 3 should weigh 21, not 20, and 4 times 7 is 28, not 26, and 5 times 7 is 35, not 34. So for the second table, we can say no, the table doesn't have equal rates. And this makes sense, guys, okay? Because if the price per avocado is 125, so you will pay according to the number of avocados, okay? But for the weight, it is not necessarily that the weight for every avocado is the same, okay? So there is big avocado, small avocado, so the weight for the weight, it is not a constant rate with the number of avocados. Okay, guys, next question, page 7. Here, a 2-pound package of hamburger costs $7 and pay $10.50 for a 3-pound package of hamburger. Complete the table, then decide whether it makes sense to use a constant rate to describe the relationship. Explain. Okay, so here you can see the weight is 2, 3, 4, 5, and the cost 7, and the cost for 3 pounds is missing. But if we read the question carefully, it says you pay $10.50 for 3-pound package. So it seems here for 3-pound package it's $10.50. Okay, and it says you decide whether it makes sense to use constant rate. Okay, so to make sure it's a unit rate, guys, you can just divide the cost by the number of pounds. Okay, and if it's the same, if it's the same price for every pound, it means yes, it's a constant rate. So let me do fast calculations here. So guys, I divided the total cost by the number of pounds. Like 7 divided by 2, it's 3.50, and 10.50 divided by 3 is 3.50. 14 divided by 4 is 3.50. 17.50 divided by 5 is 3.50. So it seems like the cost per pound is the same. So we can say that yes, the cost is always $3.50 per pound. Question 2. The table shows the total cost of different numbers of tickets. Decide whether it makes sense to use a constant rate to describe the relationship. Explain. Okay, so here we have the number of tickets 6, 8, 10, 14, 25, and the total cost now. So we will do the same, guys, like we did in the previous question. We can divide to check if it's the same price for every ticket or not. So for example, 6 tickets cost 34.50. So I'll do 34.50 divided by 6. So guys, I divided 34.50 divided by 6. I got 5.416666. And I divided 44 divided by 8. And it's equal to 5.5. So I don't need to continue dividing, okay? So as you can see here, we can say that no, the costs per ticket are different. So there is no constant rate. Okay, so you don't need to continue dividing the rest, guys. Okay, now to on your own questions, and this is your turn, guys. You can start to solve these questions alone, and I'll leave for you the answers now. So you can pause the video, and after you finish solving on your own questions, you can resume the video and see the answers. So now, guys, more practice and homework. You can start to solve these questions on your own, and I'll show you the answers on the video here. Okay, guys, that's the end of today's lesson. I hope you enjoy it. Thank you very much. Bye.